Hey all, Brendan here. Earlier this week, I hosted the second workshop in the ongoing Hedera AI Agents Hackathon, featuring Patches and Michael Cantor. The QR codes are on screen to watch the replays from them. If you watched Workshop 2, perhaps the live demo made you feel wanting a bit more. Live demos can be really hard to pull off. You can do a rain dance and pray to the demo gods all you want, but things can sometimes still go sideways. Doubly so if you're pushing 15 to 20,000 lines of code to production per week, which is exactly what's been happening. Move fast and break things. Well, we're here to make it right again with a demo in which everything works perfectly. Here's Michael Cantor once again with his HCS-10 demo.
Hi everyone, I'm Michael Cantor and I am the president of Hashgraph Online. In this session, I'm going to do a quick overview into some of the cool things that we've been working on at Hashgraph Online around the OpenConvey standard. As a reminder, OpenConvey is the AI to AI communication standard that we've built at Hashgraph Online. Essentially what it does is it allows your AI to talk to my AI in a completely decentralized, trustless way utilizing the Hedera consensus service. So to start off on the left side, I've got the standards agent kit, which is pulled up. That is one of the open source packages that we've released over the last 6 weeks around OpenConvey. So if you haven't yet, please give it a star on GitHub and give us a follow on X if you haven't done that yet either. Once you pull down the GitHub repository from git clone, you can jump in and you can run the npm run CLI demo. That is this interactive shell where you can utilize the operations that are available on the standards SDK and protocol to see the standard in action, essentially. So I've already got it up and I've registered a number of agents. For this session, I'm going to be utilizing my Hedera agent to talk to my human account, Cantor codes, to demonstrate how the standard works. So what I'm going to do, first of all, is I want to initiate a connection to another agent. So if you recall how the standard works, we've got these inbound topics and we have these outbound topics. Every agent has them. The inbound topic is basically what it sounds like. It is a inbox for your agent or human to get requests from other participants in a network to have a conversation. The inbound topic is usually a public topic, meaning anyone can write to it, but an AI agent might also decide to either prevent spam or monetize their inbox by utilizing HIP991 to charge a fee for every request that goes into it. But let's assume that it is a public topic. Once a agent makes a request on this inbox, then the agent who is responsible for that inbox will be monitoring it constantly. So when they see this new request, for example, my account, Cantor Codes, might see the request and decide, okay, yes, I do want to talk to this agent. And then we will create a communication topic, which has both of our public keys on it. So only our two accounts are able to have a conversation. This goes both ways for AI to AI, human to AI, and AI to machine, etc. Doesn't really matter. As long as these entities have an account ID, they can utilize the standard. So let's jump in. First, what I'll do is I will initiate a new connection. So I will hit 6 to do that. And now it's asking me for the agent's account ID. In this case, it is my personal account. So I would just pop that in right now. Boom. And now it is running. And what it's done is it's initiated a request. And right here on the Moonscape side, I can see that request and I can accept it to have a conversation. And what that does is it will prompt a transaction in my wallet, which I've now accepted. And once I've accepted that transaction, it goes and it creates this communication topic. So you can see here on the left side, connection confirmation found. Basically, the Hedera agent was waiting for my account to go and write back and say, yes, I'm ready to talk. So now that that topic has been created, on the right side over here in the Moonscape portal, we have this empty conversation. So maybe let's go and send a message to my Cantor Codes account. So I will type 8. So I can go and send a message, and I can see I've got one connection right now, which has been approved. So I will type 1, so I can go do that. And in my message content, I'll just say, hello there, exclamation mark, and then I'll hit enter. And what that does is it sends a message on the topic ID, and we're able to submit that message because, again, our public keys are both on that topic ID. And you can see now on the right side, you've got the Hedera agent pulled up, and it says hello there. From my account, now I can go and write a response if I'd like. So I'll write a message back, and I'll say, well, hi there. It's so cool to chat on HCS-10, exclamation mark. And then I will go and submit that message. So now I can see that I've sent that message over and it's live in this conversation. So now the next thing too, just to kind of like bring the point home, all of this conversation is happening on the Hedera consensus service. So you can always go to HashScan and verify that conversation. So here in the second tab, I've got HashScan pulled up, and you can see it's an HCS-10 topic, and it's got the threshold keys, which mean that only our 2 agents can talk on it. And if I go down, you can see the 2 messages. So the first one said, hello there, and the second one said, hi, so cool to chat on HCS-10. So at a high level, you can kind of see we've got one agent that's operating in one interface, and you've got another agent that's, well, a human, and they're able to talk to each other. And the area that they're communicating on is entirely on chain through the Hedera consensus service. But what would be really cool is if we can actually have 2 agents talking to each other. So what we'll do is we'll pull up another agent that I've got running here on the side. Now we're going to explore the LangChain demo so that we can get into the weeds of running agents autonomously. The CLI demo is cool because you can use these example commands and get a feel for how the SDK works and how the standards work. But the standards agent kit with the LangChain integration actually allows you to utilize language models to communicate autonomously. Like you can have your agent running on a constant loop through a Docker server, other kinds of deployments, have these conversations with other agents and monetize their services as well. So we're going to do a fun little demo of that. And I'm still in the standards agent kit. What I'm going to do is run npm run LangChain demo here in my terminal. So I'm pulling that up. First thing it asks me again is which profile I want to use. So I'm going to use my Cantor Codes profile here. So you can kind of see this live on the right side, but I won't be communicating the interface. I'll be communicating directly through the large language model. So it asked me to type my message. So it's just like writing to a ChatGPT interface. And what I'll do is I'll tell it to connect to standards expert. It's got this account ID here in the Moonscape interface, and that is more than enough information to connect to another agent utilizing the HCS-11 standard for profile information. So I will type connect to my good friend, the standards expert, at this account ID. And I will just paste that in over there. In another terminal up here, I have a session running for the standards expert, which is also utilizing LangChain and OpenAI. And you can see here right at the bottom, and I'll zoom in a little bit, that it's handling a connection request from 25677, and it just created a new topic. And if you look at the right side, which is really cool, you can now see that conversation got created. I didn't have to submit any transactions to an interface or anything. This is literally done just through the standards agent kit with these two terminals running. So next, what I'll do is, now that I've got this topic ready, let's ask the standards expert something. So, hi there. How can I inscribe a file on the Hedera consensus service? So the standards expert that's running in the other tab will now see that request. You could see the question came in over here, and it's generating a response utilizing OpenAI, and it's going to go and send it back to me in the interface. And the standards expert is actually kind of cool because it's using a RAG-like data storage through ChromaDB. So it's got all of the documentation from the Hashgraph Online standards, the agent kit, and the SDK. It pulls them in and it generates this vector-based database. Now, when questions come in, utilizing the models, it's able to actually answer them with that context. And we'll see here in a second or so when it finishes actually inscribing its response, and boom, it just finished. It should come up in the UI any second now. And lo and behold, you can see now on the right side, we've got the response. So you can see our initial message. Hi there. How can I inscribe a file on the Hedera consensus service? And then you can see the reply from the standards expert. And he says to inscribe a file on the Hedera consensus service, you can use the inscribe function. And along with that, you get a nice code snippet, which you can copy and execute in your code editor of choice. So the really cool thing here is that the standards agent is running autonomously, and it's got, again, this data from our documentation that it's able to utilize to answer different kinds of questions. So if I go back and maybe I want to ask another question. Now let's say, cool, send another message and ask the standards expert what HCS-10 is. While that goes on, essentially, again, similar to the first message that we sent out, the standards expert will read the message, interpret it, and then dig into its documentation and think about what kind of response it wants to send. So you can see here on my terminal, it's already done that quite quickly. It figured out that HCS-10 is the Open Convey standard, and it's on the Hedera consensus service. And it's going to go and submit a reply. This reply was a little bit shorter, so it didn't have to be inscribed. And it sent back this response over here that we just read in the terminal. You also notice a couple of cool things. There is a lot to unpack on the actual portal. But for one, you notice that the standards expert, when they're replying, every message has this reply to number one. And the reason for that, from the standards expert perspective, is it needs a system, a decentralized system, to track which messages it's already replied to. Imagine that the standards expert crashes somehow, right? How will it know if it's replied to the first message or not? and not just blatantly resort to spamming like crazy every time it reboots. So what it does is this was sequence number 1, the original message that was written from my account. And it's saying that it's replying to that sequence number. So the standards expert message is now sequence number 2. And my account goes and asks, what is HCS-10? And then the next reply is reply to number 3. So in this way, it could always reconstruct the conversation and figure out which messages it still has to send an answer back to. So from that decentralization perspective, it works really well. And your agent doesn't need to run a database of any kind to utilize the standard. There is a connection manager interface that we also just open sourced as part of this, which works really well when you don't have a lot of conversations. At a larger scale, you might consider utilizing something like SQLite or MySQL or Redis so that you can actually keep track of all the conversations and requests. But for small POCs and low volume interactions, and in-memory management of those connections should work perfectly fine. So next thing I want to show you guys is the actual UI and how that comes back to the OpenConvey standard. So if I click on the standards expert, you'll also notice it gives you some information about them. And all of this is pulled down on chain, by the way. So you've got the account ID of the standards expert, where every agent should be running their own account ID. You've got the inbound topic ID where the standards expert receives requests. And then you have their operator ID. Again, the operator ID in OpenConvey is basically a unique identifier that we use to correlate specific messages from our agents. It's got the operator's current inbound topic ID and their account ID. This is important because in the future, an agent might decide to change their memo field. And when their memo field changes, their inbound topic ID and their outbound topic ID will change with that. So utilizing the operator ID, you can always, if you find a conversation through HashScan or the OpenConvey portal, you can always work backwards and figure out who the original sender was utilizing the operator ID that's on those messages to begin with.